Graph the function shown. Identify the period, domain, and range. So here we have a tangent function. F of x equals the tangent of pi over 2 of x minus 1. Okay, so let's look at the transformations. This pi over 2 is going to be a horizontal shrink. Pi 2 over pi. And this x minus 1, that's the translation 1 to the right. So what I'm going to do is I'm going to graph g of x equals tangent of pi over 2x. And then I'm just going to translate it one right. So the period of the function, g of x equals tangent of pi over 2x. Well, it's a horizontal shrink by 2 over pi, but really all you need to do is pi over b. And that is pi over 2, which is pi over 1 times 2 over pi, which is 2. So the period's 2. So I think it'll make sense if I just go 1, 2, 3, 4. So the graph isn't going to be in terms of pi, it's going to be in terms of integers because of the transformation of the horizontal shrink by 2 over pi. That'll mean negative 1 here, negative 2, negative 3, negative 4. Okay. So we're graphing a tangent function with a period of 2, and it's going to be centered at the y-axis. Okay, so I'm going to switch colors here because this is going to be the graph that we're transforming. And we got an asymptote at negative 1 and at 1. That'll give us a period of 2. Another one at 3, another one at negative 3. So the space between the asymptotes is 2 because the period is 2. And since it's a tangent function, it is centered at the y-axis. That means we would have a 0 here. And then the key points, there's no vertical stretch or shrink, would just be like this. The x-intercept will be here at 2. And that's because the 2 is halfway between the asymptotes, 1 and 3. Put the key points, graph it like that. Okay, so you get the idea. And I could do one more over here, I suppose. Halfway between the asymptotes is a 0. Key points. Okay, so that's a graph of g of x equals tangent of pi over 2. Now I'm going to translate it 1 to the right. That means everything translates 1 to the right. The asymptotes, the zeros, the key points, the whole deal. So I'm going to asymptote at 4, 2, 0, negative 2, negative 4. Now the disadvantage here is that the graph starts to look kind of messy. That's why I use different colors. So try to keep in mind that I'm working on the red now. So all I'm doing is I'm translating the graphs 1 to the right. So I'm going to translate each 0 to the right 1, and then the key points to the right 1, here and here. Now try to remember that the x scale, each square I did by 1/2. So when I say translate by 1 to the right, it's actually 2 squares to the right that you're moving. Here's the next one. Okay, so what I did is I just moved every key point to the right 2 squares or 1 because my scale is 1/2 for each of these squares. And the final graph is in the red. Okay, now what's the period, domain, and range? Again, we're focusing on the red. And the asymptotes, those are at x equals 0, x equals 2, x equals 4, so on and so forth. So I can say the domain, x is an element of the real number set such that x is not equal to 2n, because the asymptotes are at multiples of 2. 0, 2, 4, 0, negative 2, negative 4. And the range, since it's a tangent function, simply say y is an element of the set of real numbers. And finally, the period of the function we already said is 2. So I'm just going to write that down here. Period is 2. Okay. So when you're making these graphs, colored pencils can be a big help. It helps you keep track of the original graph plus the transformed graph. So make sure you graph the original function without any translations, and then you just translate the function whichever way.